Hi you two, welcome back to another video on division. This time we're going to do things a bit differently. In our last video we looked at division by sharing. Today we're going to have a look at division by grouping. Let's get straight into it. I've got a word problem here. There are 12 children all together. They sit in rows of 3. How many rows will there be? Okay, there's 12 children all together. They sit in rows of 3. I'm looking for how many rows there are going to be. If we get our other whiteboard out, we know the whole here. There are 12 children altogether. The number of groups and the value. My goodness, sorry for my handwriting. Okay, we know the whole is 12. They sit in rows of 3. I'd actually really like to pause on that. Rows of 3, it sounds really confusing because immediately you might think, oh, so there's 3 rows. But rows of 3 means that children sit in rows and in each row there's 3. Rows of 3, rows with 3 in each row. This time we're looking for how many rows there are going to be. So we do not know the number of groups or the number of rows, but we know the value of each row or the value of each group is 3. To put this into an equation, we can say 12 divided by 3 gives us something. The whole divided by the value of each group will give me the number of groups. Okay. The first thing I'm going to do here is I'm going to get my whole ready. I'm going to use my counters again and I'm going to count out 12. 1, 2, 3, 4, 5, 6, whoops, 7, 8, 9, 10, 11, and 12. Sorry, let me just check. 3, 6, 7, 12 counters. Great. Now, this time I need to group them. I can't draw out those empty rows because I don't know how many rows to draw. Instead, I can start preparing my groups of 3 or my rows of 3. So I'm going to do that. I'm going to get 1, 2, 3. That's one group. That's one row. Maybe I'll draw the rows as I go along, just so I don't confuse myself. 1, 2, 3. That's another one. 1, 2, 3. That's another one. 1, 2, and 3. That gives me my last one. Ah, interesting. So I've made my groups of 3 for my different rows. Okay. I can see all of my 12 counters have been shared equally. Just to check, let's make sure I have got my groups of 3. 1, 2, 3. Oh, whoopsie. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yes, each row has got 3. But I was looking for the number of rows. Let me count them up. 1, 2, 3, 4. There are 4 rows. I can say 12 divided by 3 gives us, oh, sorry, let me get this one. Gives us 4. My whole 12 shared into groups of 3, the value of each group, gives me 4, the number of groups. 12 divided by 3 gives me 4. I've lost there it is. I was going to say I've lost a counter. Right. I've done this in one way. There's actually another way that I can represent this information. This is an array. I can also represent this using a part-whole model. Let me just move all my counters across to down here. Oh, let me rub that out. Just like we use a part-whole model for addition and subtraction, we can actually still use part-whole models for multiplication and division. I start with my whole, which is 12. Now, I was looking for the number of rows. I've now worked out that there are 4 rows, so I can actually draw 4 parts. I'm just working out to make it fair. 1, 2, 3, 4. Sorry, it's not super neat, but I have to make do. Right. I have my whole, which is 12, and I'm dividing 12 into 4 equal parts. I can do this using my counters, but I just don't think they'll fit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Just imagine all of them fit into that hole. My hole is 12, and I've shared them out into my 4 equal groups. Just to check that I've done it correctly, I can actually just go 1, 2, 3, 4, 1, 2, whoopsie, 2, 2, 3, 3, 3, 3. My hole is 12, and there are 3 in each group. Yes, I've done it correctly. Now with this part hole model, we just need to know that for maybe to be able to draw the part hole model, I need to know the number of groups. If I don't know this number, I can't draw this model. The only reason I'm able to draw it now is because I've worked out that the number of groups is 4. If I know the whole and the number of groups, I can use this to represent that information. But without the number of groups, we can't use our part whole model. So we need to work that out. But we have worked it out. We've worked out there are 4 groups and there are 3 in each group. It's just another way that we can represent that information. Okay, I've done one. I'm going to give you a question to try now. And again, I would really love if you posted what you do and how you do it on Seesaw, whether it be a video, whether it be a post or a picture. I'd really love to see. Okay, I hope you continue to have a really amazing holiday and get lots of rest in. Okay, team, this is your question. There are 20 children altogether. They sit in rows of 5. How many children are in each row? Let's underline that key information together. There are 20 children altogether. They sit in rows of 5. Just remember, rows of 5 means rows with 5 in each row. How many children are in each row? Sorry, that is not the right one. It should say how many rows are there. How many rows will there be? Okay, you're looking for the number of rows this time. So remember, we're doing division by grouping. Again, if you don't have counters, feel free to just draw it out. That is completely fine, and that's what you would do when you're using paper or in a test. Right, I can't wait to see what you do.